Okay, right now we're going to go ahead and start section 4.4 material, and I will be using the marker board. I was going to try to use the smart board, but it wasn't working quite like it should, so I am going to do it the old-fashioned way and use the marker board and talk about the material from there. If you could make sure you have your book out and looking at section 4.4, I will be following that book and a PowerPoint that I have on the book to present the material. Okay, so first of all, we are talking about section 4.4, and that title, of course, is complex numbers. Now, complex numbers is a set of numbers that is actually beyond real numbers. We've talked about real numbers in the past. We've talked about real numbers, basically rational or irrational numbers, and complex numbers is the number set that actually encompasses the real numbers. It also encompasses what we call imaginary numbers. Now, imaginary numbers is another set of numbers within that complex number set. And so, basically, a complex number is made up of a real number and an imaginary number together. So every number in the complex number set can be written as a plus bi, where the real number part is a and the imaginary part is bi. Now let's talk about what I is. I is called an imaginary unit. I is an imaginary unit where I is equal to the square root of -1. Now, we've never been able to take a square root of a negative. If you type it in your calculator, the square root of a negative number, for example, if it says the square root of -4, your calculator is going to say it's unreal. It's not a real number, or non-real, I guess I should say, non-real. Now, a non-real number, meaning imaginary, and some of your newer calculators might actually use the I unit on the calculator, but that's what an imaginary unit is. So when you see I, you know that that is an imaginary unit. Now, a pure imaginary number is when the real number part is 0. So for example, if you have 7i, that's an example of a pure imaginary number. Now, let's go ahead and talk about how and why we use imaginary numbers. So, because we talked about simplifying radicals, when you have a negative number underneath the square root sign, so for example, the square root of -4, this now is made up of two numbers, the square root of -1 and the square root of 4, which of course, the square root of -1 is I, the square root of 4 is 2, but then we always write it as 2i. We always put the I in the back, just like we would with a variable. It's not a variable, it stands for the square root of -1, but we write it this way, 2i instead. Okay? All right. Now, let's go with the square root of -28. if we were to simplify this one, anytime there is a negative underneath the square root sign, it's going to come out as I, because it's the square root of -1, in this case the square root of 4, and times the square root of 7. So we're using the product property of roots to break it up, and then of course this is 2, this is I, and of course then the radical is last, so 2I square root of 7. All right, square root of -32. Okay, so there's two ways you can do this. One way is to think about a perfect square inside, just like we talked about. So we've got the square root of -1, we have the square root of 4 squared, which is 16, and the square root of 2. So this again, square root of 4 squared is just 4, square root of -1 is I, and the square root of 2 is square root of 2. All right, so here's one that you should try. I would like you to try the square root of -50. Simplify this . Pause the computer, try that, and then I will see if you get the right answer. Okay, so hopefully, I'm going to check to make sure we can see this. I don't want to get too far over. Okay, so I'm a little bit, there we go. So the square root of -50, you should have the square root of -1, the square root of 25, and the square root of 2. So this answer should be 5I square root of 2. Anytime you have the square root of a negative, it comes out as I. All right, now we are going to multiply imaginary numbers, pure imaginary numbers, okay? Now, let's just talk about this for a second. Before we actually multiply pure imaginary numbers, let's talk about what happens when you square I. Now, with this said, let's go ahead and we already know that I is I, okay? I is the square root of -1. So we know that I is I. Now, every number, remember, can be written in the form of a plus bi. So there is no number that has I to a power other than 1. And so what we want to do is we want to be able to write every number in terms of I to a power of 1. Okay, so what would you think I squared is? Okay, so if you think about what I equals, and if I'm going to square I, that's like squaring the square root of -1. Well, all that's going to happen is that square is going to cancel out the square root, so I squared is the same as -1. Okay? All right, what happens when you cube I? Well, that's the same as I cubed is the same as I times I squared. Since I is I squared is -1, this is just -I. So if you ever have an I cubed, it's just -1. How about I to the 4th? Now I to the 4th is I squared times I squared. So I to the 4th is -1 times -1, which if you have I to the 4th, that's the same as +1. Now this actually repeats, because if you think about it, I to the 5th is now I to the 4th times I. Well, I to the 4th is 1. 1 times I is just I. So when you get to I to the 5th, it's just the same as I. I to the 6th is now I to the 4th times I squared. So I to the 6th is the same as -1. I to the 7th is the same as -I. I to the 8th is the same as I to the 4th. And then it repeats. I to the 9th is I to the 10th is -1, I to the 11th is -I, and I to the 12th is 1. So as you can see, every 4th number it repeats. So with that said, you should be able to tell what something to I to a power is by just using that pattern. So for example, what is I to the 23rd? Okay. I to the 23rd, we know I to the 24th is a power of 4. We know I to the 24th is a power of 4, or multiple of 4, excuse me, so it's 1. I to the 23rd then would be the same as I to the 3rd, which is -I. So you're always referencing yourself to a multiple of 4 for the power. So let's say we have I to the 60th. I to the 60th, is that a multiple of 4? Yeah, it's 4 to the times 15. So therefore, this is just 1. If I had asked you what I to the 59th is, you would have said -I. If I would have asked you what I to the 61st is, you would have said, well, that's the same as I, because it starts over at that point. I to the 62nd is 2 more than I to the 60th, so it's the same as I squared, or -1. Okay, so try this. I will give you a couple. You tell me what they are. Pause your video, and then I will go over them when you're done. Okay, so let me just think up a couple. Let's say that you have, what is I to the 35th? What is I to the 92nd? Okay, pause your video, get that done, and let's see what you get. Okay, so I to the 35th, I think of a multiple of 4 that's close to 35. Well, 36 is a multiple of 4. So I to the 36th is 1. 35 is 1 before that. So that's the same as I to the 3rd, which is -I. I to the 92nd. Divide that by 4. Sure enough, that is a multiple of 4. So this is the same as I to the 4th, which is just 1. Okay, if I would have given you one more, let's say I gave you I to the 70th. Well, I to the 72nd, let's put it underneath here, I to the 72nd is the same as I to the 4th, which is 1. I to the 71st is the same as -I, so this is -1. That's the same as I squared. Okay? So looking for a pattern with the powers of I. Okay, that's something. Now, where we're going to use this, and we're going to use this later on in the book, and you're going to see this a lot in the future, but where we're going to see this the most right now is when we multiply 2 imaginary numbers together. So let's try that. All right, so as of right now, really all you need to do in this example is know that I squared is negative 1. Okay, so for example, if I multiply negative 3i times 2i, well, this is just like multiplying two numbers with a variable, actually. It's the same as negative 3 times 2 times I. So this is negative 6i squared. Now, we should not ever write a number with I to a power other than 1. And so we should replace this with negative 1. So the answer is positive 6. Because negative 6 times negative 1, since I squared is negative 1, we multiply those two and we get positive 6. All right, let's try this one. Here's another example. Let's go with the square root of negative 12 times the square root of negative 2. Now, we talked about the fact that you can multiply underneath the radical sign two numbers underneath as long as they're both underneath the radical sign. However, in this situation, you should simplify them first and then multiply them as they are. Okay, so for example, the square root of negative 12 is 2i square root of 3. The square root of negative 2 is I square root of 2. When I multiply these together, I get 2i squared square root of 6. Hence, the square root of 3 times square root of 2 is the square root of 6. Which leaves me with, this is negative 1, so it's negative 2 square root of 6. There's my solution, or product. All right, here's a check your progress. Try this on your own. Again, just go ahead and pause your computer once I give you the problem and you try it. So 3i times 5i, and then I'll give you one more. The square root of negative 2 times the square root of negative 6. So try those two problems and let's go ahead and see if you get the right answer. Okay, welcome back. All right, the first one, when we multiply, it equals 15i squared. We should never have I squared, so we would change I squared to negative 1 because they are equal. And so this answer is actually negative 15. The second one is I square root of 2 times I square root of 6, because the square root of 6 doesn't simplify. When we multiply this, we get I squared square root of 12. Now, if you notice, the square root of 12 can be simplified now. It's the same as the square root of 3 and the square root of 4. So my answer for the square root of 4 is 2. I squared is negative, and then the square root of 3. So the answer to this is negative 2 square root of 3. Let me show you one more time how I got that. I got I squared, which is negative 1. I got the square root of 4, which is 2, and the square root of 3, which is the square root of 3. So there's my answer, is negative 2 square root of 3. All right, now, since we were learning how to solve quadratic equations using square roots in the pre-4-4 part, we're going to use that concept now with problems where you actually will have imaginary solutions. So if you recall, we had 5x squared plus 20 equals 0. Now, if I'm going to solve this, remember what we did was we used the fact that we wanted to get x squared by itself. So we subtract 20, I get 5x squared equals negative 20, divide by 5, I got x squared equals negative 4. Now, if you recall when we did this, we took the square root of both sides, but once we did that, we had to do plus and minus. Do not forget that. The square root of x squared is just x. Plus or minus, the negative, of course, comes out as I, and then the square root of 4 is 2. So I have two solutions. I have plus 2i and negative 2i for solutions of this equation. Okay, I'm going to have you try this one. Okay, so here's a try this problem. Example, 2x squared plus 50 equals 0. Go ahead and try this, solve it, pause your computer, so I will go over it here in a minute. Okay, welcome back. If I'm going to solve this one, I'm going to subtract 50. I get 2x squared equals negative 50. Divide by 2, I get x squared equals negative 25. When I take the square root of both sides, I get a plus and minus. X equals plus or minus 5i. There's my two solutions. Okay, talking about complex numbers. I already introduced you to complex numbers, and we are going to go ahead and talk a little bit more about complex numbers, and then we also want to introduce you to what we call the complex conjugate. Okay, so we said a complex number is in the form of a plus bi, where a is the real part, b is the imaginary part. Every number can, actually bi, I should say, bi is the imaginary part. Every number can be written in this form. Okay, so even if you have a number such as 7, this is a real number, but as a complex number, it's written as 7 plus 0i. So the a is 7, the b is 0. It's written as a complex number. Okay, so 7 is just a real number, but 7 plus 0i is a complex number. Equate in complex numbers. Well, when you have a plus bi, and let's say though that is equal to c plus di. If these two complex numbers are equal, then a is equal to c and b is equal to d. Okay, because the real number parts are going to be equal and the imaginary coefficient is going to be equal. So what they're going to ask you in this is find the values of x the value of x and y that make the equation true. And so what they're going to do is they're going to give you two complex numbers, one with variables in it and one without. So for example, they have 2x plus yi is equal to negative 14 minus 3i. Okay, so if you notice, they have two complex numbers that are equal to each other. So to make this true, we know that 2x has to be equal to negative 14 because those two parts are the real parts. So x is negative 7. The imaginary parts, the b and the d, also have to be equal. So y has to be equal to negative 3. So the value of x that makes this complex number equal to this one is negative 7. The y value that makes this complex number equal has to be negative 3. Okay, so you try this one and see if you get it. All right, so here's where we're at. So here's a try this problem. If I set 3x minus yi equal to 15 plus 2i, what does x and y have to be to make this true? Pause the video and go ahead and try this. Okay, so what you should have done was you should have set 3x equal to 15, so x is equal to 5, and you should have set negative y equal to 2, so y is negative 2. So 5 and negative 2 are the values that make that true. Okay, I'm going to keep going. I was going to stop here, but I'm going to keep going with the rest of it. There's a little bit more to this section, as you can see. The next subject that we're going to talk about is to add complex numbers. Now, if I'm going to add complex numbers, basically what I'm going to do is I'm going to take two complex numbers. Let's say you have 3 plus 5i, that's one complex number, plus I'm adding another complex number of 2 minus 4i. Okay, so just like before, if I'm adding two complex numbers, I am going to pay attention to the real parts. If I'm going to add two complex numbers, the real part of the complex answer is going to be 3 plus 2, which is 5. The imaginary parts are going to get added together as well. In this case, I have 5i plus a negative 4i. When I add those two together, I get positive 1i. So my addition of these two complex numbers, or sum, is 5 plus I. Pretty simple. You just go ahead and add like terms, basically. Okay. Likewise, if I'm going to subtract, for example, 4 minus 6i, if I'm going to subtract 3 minus 7i, I go ahead and I can do this a couple ways. I have 4 minus 6i, but then if I distribute the negative, minus 3 plus 7i. So there I'm going to go ahead and now I'm adding 4 minus 3. So that's positive 1. And then I'm going to add negative 6i plus 7i, which is just plus I. So when I subtract, I'm basically taking the 4 minus 3, which is 1, negative 6 minus a negative 7, which is positive 1i. Okay, next we are going to multiply two complex numbers. Okay, we're going to multiply two complex numbers. Now, let's try that. Let's give you a complex number, let's say 2 plus 3i, and I am going to multiply this times a complex number, let's say -1 minus 4i. Okay, when I have two complex numbers that are being multiplied together, it's just like multiplying two binomials. Okay, so if I actually was going to multiply x plus 4 times 2x minus 5, what would I do? And most of you are going to say you FOIL it. Okay, you would FOIL. You would get 2x squared minus 5x plus 8x minus 20. Very similar. So what I would get was 2x squared plus 3x minus 20. Now, in complex numbers, it's very similar. You multiply two complex numbers, you FOIL it, basically. You're going to take the 2 times -1. You're going to take the 2 times -4i, which is -8i. 3i times -1 is -3i. And then the last ones is 3i times -4i, which is -12i squared. Now remember, when we multiplied pure imaginary numbers, the I squared was the same as -1. So that makes this plus 12, because it's -12 times -1. So now I'm going to go ahead and add the real parts, which is 10. I'm going to add the imaginary parts, which is -11i, and so there's my complex number, 10 minus 11i. Remember, all answers can be written in complex form. Now, they have a problem, a real-life problem in the book with electricity, and they say that E is equal to, and I believe that is a current, is that L times Z, impedance. Now, E as in voltage is equal to L, the current L, times the impedance Z, and they say that the current is it is 1 plus 4i, or I guess they use J, but it's very similar in this case to I. And then the impedance is 3 minus 6i. If I am going to find E, it's 1 plus 4j times 3 minus 6j, and we're going to FOIL it, just like we did here. So we get 1 times 3 is 3, 1 times -6j, 4j times 3 is plus 12j, minus 4j times 6j is -24j squared. And again, just like I, this is the same as -1, so that makes this plus 24, because it's -24 times -1 gives me 27 plus 6j. Okay, so -6 plus 12 is plus 6. So therefore, this is my voltage. All right, the last thing we're going to talk about with complex numbers is simplifying. Okay, so give me some room on the board here. The simplifying with dividing complex numbers, we have for example, 5i over 2 plus 3i. Now, according to simplification rules, you're not supposed to have an I in the denominator of a fraction. Because when you think about standard form or complex form, you don't have I in the denominator of a fraction. Okay? So what we're going to have to do is we're going to have to get rid of the I from the denominator. To do that, we need to have the complex conjugate of that number. So the complex conjugate of a plus bi is a minus bi. Okay? Now, the reason that those are conjugates is because when you multiply them, the i's will cancel, and I'm going to show you that. So basically, to simplify this, to get rid of the I from the denominator, we need to multiply the denominator by the conjugate, which is 2 minus 3i. Now, you don't just multiply the denominator by the conjugate, you also have to multiply the numerator, because really what you're doing is multiplying by 1 something over itself. Okay? So the object here is to get rid of the I from the denominator by multiplying by 1, which is something over itself, and that something is the conjugate of the denominator. Okay? So when I do that, when I multiply, I am going to go ahead and FOIL the denominator, which ends up to be 4 minus 6i plus 6i minus 9i squared. This ends up to cancel those i's out. Of course, I squared is -1, which makes this a positive 9. So the denominator is 13, which no longer has an I in it. Now the numerator, what we're going to do is distribute. So we end up with 10i minus 15i squared, which of course becomes positive 15 plus 10i. Now, there's our number. However, that's not in complex form yet. Complex form actually is the two separate numbers, a plus bi. So what we want to write it as is 15 thirteenths plus 10 thirteenths I. So we know that a is 15 thirteenths, b is 10 thirteenths. So those two numbers are a and b. So this is my answer when it is written in complex form. Now again, you can go back and review this or rewind this video and watch that again. I'm not going to go through it again just to save us some little bit of time. There's also tutorials in the back or that I've posted out of Connect Ed, the online book. So if you need help with this, go back into Connect Ed and look at those tutorials and watch them. They should have similar examples. Now, the next one I want to show you is basically when you have just an I in the denominator. So for example, if I have 5 plus I over 2i, this time I am going to multiply the top and bottom by just I. And the reason is because I don't need to multiply by the 2 to get rid of the I. All I have to do is multiply by I. And the reason is here, this becomes now 2i squared, or just -2. The numerator becomes 5i plus I squared, which of course is -1, so -1 plus 5i. Now I'm going to go ahead and rewrite this as 1/2 minus 5/2 I. That is the number in complex form. And that's it. That concludes section 4.4. I know that was a long section, but it would have been a long section in class, and it would have taken most of the period to cover it. Hopefully you get it. Hopefully you're able to go on and find some extra help if you need it, or you can questions. I will be doing the Google Meet at 1 o'clock on Monday. So if you have questions, let's go ahead and get on to Google Meet. I'm going to post about that on Monday, so hopefully we can get all that sorted out. All right, thanks, and let me know if you have any questions.